Hello everybody. Today we are going to discuss some questions based on the chapter Dual Nature of Radiation and Matter. First question is, electrons are accelerated through a potential difference of 150 volts. Here the mass and charge is given and also Planck's constant is given. We have to calculate the de Broglie wavelength of electron. There's a special equation for it. The actual relation is lambda equals h by mv. This is the de Broglie wavelength. But we have half mv square equals ev, so that we may write lambda equals h by root of 2 mev. But we know the mass of electron, charge of electron and h are all constants. For an electron, by putting mass of electron as 9.1 into 10 raised to minus 31 kilogram, charge of electron as 1.6 10 raised to minus 19 and h as 6.6 10 raised to minus 34, then we may get an equation in the short form as root of 150 by V angstrom. This is applicable only for electrons. Here, the voltage applied is 150 volt. Hence, we may use this equation, simple equation, lambda equals root of 150 by 150 angstrom. This relation is applicable only for electrons. Otherwise, we may use this equation, and here the answer is 1 angstrom. The correct answer is option B, it is 1 angstrom. Now the second question. Again we have to calculate the de Broglie wavelength of a particle of 1 angstrom wavelength. We have the de Broglie wavelength is given by lambda equals h by p. The momentum p equals h by lambda. Here the wavelength is 1 angstrom. H is 6.6 into 10 power minus 34. Wavelength is 1 angstrom. 1 into 10 raised to minus 10 meter. Now we'll get the value as 6.6 into 10 raised to minus 24 kilogram meter per second. Hence the correct answer is option C. It is 6.6 into 10 raised to minus 24. Now third question. If a proton and electron have the same kinetic energy, then the ratio of the de Broglie wavelength of proton and electron are approximately ratio of the de Broglie wavelength of proton and electron, same energy. We have the relation lambda equals h by root of 2 mev, but ev is the energy. Then we may write h by root of 2 me. In this question, it is stated that they have the same kinetic energy. Kinetic energy is same. That is, E is a constant. H is already a constant. That means lambda proportional 1 by root m. Ratio of the wavelengths of proton and electron. Mass of proton is 1847 times the mass of electron. That means lambda of proton by lambda of electron equals root of mass of electron divided by mass of proton. Inversely proportional to 1 by root m. Lambda of proton by lambda of electron equals root of mass of electron by mass of proton. Here the mass of electron may be me and the mass of proton is 1847 me. That means 1 by root of 1847. It is of the order of like this. We may know the square root of 1847 will be nearly 43. The answer is 1 by 43, 1 is to 43. Hence the correct answer is option D, The answer is 1:43. Now there is question number 4. The de Broglie wavelength of a neutron at 27 degrees Celsius is equal to lambda. The wavelength at 927 degrees Celsius, we have to compare. That is, calculate wavelength at 927 degrees Celsius in terms of wavelength at 27 degree. Again, we have the relation lambda equals h by root of 2me. E is the kinetic energy, that is E equals half mv square. For a gas molecule, we have energy is given by 3 by 2 kT. That is, we have mv square equals root of 3 kT or half mv square. I may put it as energy E equal to root of 3 by 2 kT. I may put like this, lambda equal to h by root of 2m into 3 by 2 kT. Instead of half mv square, I may put it as 3 by 2 kT. Then we will get the relation. Kinetic energy is 3 by 2 kT, h by root of 3 mkt. The relation shows that lambda proportional 1 by root t. Here, first temperature is 27 degrees Celsius. I may call it as T1, which is equal to 27 degrees Celsius equal to 27 plus 273. That means 300 Kelvin. This is the first temperature. And the second one is 927. T2 equals 927 plus 273 is equal to 1200 Kelvin. Like this. Then we may calculate like this. Lambda at 27 by lambda at 927 is equal to root of this one 927 plus this 270, that means 1200 divided by this 27 degree, that means 300 Kelvin. It is root 4 is equal to 2. Here it is stated that lambda at 27 degrees Celsius is lambda and the other one is lambda 927. That is, lambda at 927 is equal to lambda by 2. Hence, the correct answer is option A, it is lambda by 2. Next is question number 5. Which of the following is not the property of cathode ray? Simple question. As you know, cathode rays are electron beams having negative charge. Option A, it produces heating effects. Option B, it does not deflect in electric field. The option C, it produces fluorescence. And D, it casts shadow. You know, A, C and D are the properties of electron beam. That means properties of cathode rays. But being negatively charged, it will be deflected by electric field. Hence, if it is given that it is not deflected, hence the option is wrong. The wrong answer is option B, does not be deflected in electric field. Not the property is option B, not deflected by electric field. Now it is question 6. Monochromatic light of frequency 6 into 10 raised to 14 Hertz produced by a laser. The power emitted is 2 into 10 raised to minus 3 watts. Number of photons per second. We have E equals h nu or power P equals n h nu. Then n equals power divided by h nu. Here the power is 2 into 10 raised to minus 3 watts. H you know 6.6 into 10 raised to minus 34. This is the power. And then frequency. The frequency is 6 into 10 raised to 14 Hertz. On dividing we will get, here may be around 2, that means 20 into 10 raised to minus 4. Here it is almost 40. Then into 10 raised to minus 20. That means 1 by 2 or 0.5 into 10 raised to 16. This will reach to 5 into 10 raised to 15. Hence the answer is to be option A, 5 into 10 raised to 15. Next is question number 7. The threshold wavelength of sodium is 5420 angstrom. Then the work function of sodium is, the work function is the minimum energy required to emit electrons. That means E equal to h nu 0. Here we may calculate like this. E equals h nu 0 equals h into C by lambda 0. H 6.6 10 raised to minus 34. C 3 into 10 raised to 8 by lambda 0 5420 into 10 power minus 10. Angstrom can be converted to meter by multiplying with the 10 raised to minus 10. This much is joule. Here all the units are in EV. To convert into electron volt, we may again divide with 1.6 into 10 power minus 19. Along with this, we may put 1.6 10 raised to minus 19 to get EV. 6.6 10 raised to minus 34, 3 into 10 raised to 8, all are here. Here also this will be almost 20. Then 10 raised to minus 26, minus 34, 8. Then I may take like this, 5.42, then 10 power 3 and 7, minus 7. Then we have 1.6, 10 raised to minus 19. Here it will be 20 by 5.4 into 1.6 is almost 9. Then 10 raised to minus 26 cancels and it will be nearly 2.2 or like that. Here the correct answer is 2.28 EV. Option B is the correct answer. Now there is question number 8. Which of the following phenomena can describe quantum nature of light? Light is having two nature, namely particle nature and wave nature. The wave nature of light can explain the properties of light like polarization, diffraction, interference, etc. By using Huygens principle, we may even explain the principle of reflection and refraction also based on wave theory. But wave theory cannot explain the two properties, namely photoelectric effect and Compton effects. We have to study only photoelectric effect related to it. By using the principle of photoelectric effect, we can show that there is some defects for wave theory. Here, quantum theory can explain photoelectric effect. Here the correct answer is option A. Next question. The maximum energy of electrons released in a photocell is independent of. You know that as intensity increases, number of photoelectrons increases. As a result, photoelectric current increases. As frequency increases, the energy increases. You know that kinetic energy is directly proportional to frequency. Also, depending on the nature of cathode, we can calculate the energy. That is, as intensity of incident light increases, number of photoelectrons and photoelectric current increases. Here, the maximum energy is independent of intensity. Hence, the correct answer is option B, intensity of light. Question number 10. This is the last question related to this chapter. The question is like this. The maximum velocity of photoelectrons emitted on a metal surface is 1.2 into 10 raised to 6 meter per second. Specific charge is given as 1.8 into 10 power 11 coulomb per kilogram. Value of stopping potential is, we have to calculate the stopping potential. Stopping potential is the voltage potential at which photoelectric current stops, the opposing voltage. For this, we may use the relation, the kinetic energy half mv square and the opposing energy EV0. V0 is called the stopping potential. V0 equals half mv square divided by E. I may write like this, half 1 by E by M and then V square. That is V square, it is 1.2 into 10 raised to 6 whole square. It is V square 1.2 10 raised to 6 and then 2 into specific charge is called E by M. Specific charge. E by M is called specific charge. That is, we have put E by M as 1.8 into 10 power 11. Here the answer is like this. 1.2 square it is 1.44. Then we have 10 raised to 12 divided by 3.6 into 10 power 11. And here I may write like this, 14.4 by 3.6. The remaining is 10 raised to 11. Here also 10 raised to 11 cancels and this to be almost, it is 4. The correct answer is option C, it is 4. You know, dual nature is an important chapter. There are a lot of questions related to this chapter. The main thing is that we can show that there is some defects in wave theory. That is, wave theory cannot explain certain phenomena of light. Okay, study this well. You can do a lot of problems connected to this chapter to get better score in theory and in entrance examinations. Okay, best of luck to all of you. Thank you.